Hello, everyone. I think it's time to start. First of all, I have to apologize. I think you were all expecting to see Jan Ouwens, who is a guy who works at Codestar and who did EqualsVerifier. I'm not him. Yeah, I'm actually his double from a parallel universe. And somehow I got stuck here. Which is sad. But, you know, since I'm stuck here, I'm trying to make the best of it by giving you this talk, right? I've actually seen many parallel universes until my thingy broke. And yeah, I don't know how to get home. But I have seen a lot of universes. So maybe you would like to know how your universe ranks across all of the universes that I've seen and that I've known of. So let's take a look. You guys are... Okay. Still, you know, quite high, I guess. I mean, you guys are burning your planet for Bitcoin, so I don't know. That's more like it. I said this thing is broken. You know, it's still a big number, maybe bigger. Oh, I'm sorry. Well, it's still finite, right? Well, okay. I'm sorry, but you know, I can help you with that. After this session, we will be able to raise your level by at least 100 points. So that's nice, right? I'm going to help you. How am I going to do that? Well, you know, since I'm stuck here, I had to find a job. So I started doing whatever I do well, which is programming in my case. But I'm used to doing it a little bit differently than you guys are. So to help me make my point, I want to talk about the language of the year. Who knows about language of the year from the pragmatic programmers? Nobody. Oh my God, you guys have a lot to learn. They have proposed that you learn a new language every year, just to increase your skills, to increase your knowledge. You don't actually have to use the language for anything, but if you learn it, you will learn new things, new concepts, and that will make you appreciate the languages that you do use a bit better. You can apply the knowledge that you learned from those other languages in the language that you use, which is probably Java in your case, I hope. Some hands, maybe? Okay, that's good. At least you all know Java. That's nice. Okay, so what I am proposing is that your language of the year should be parallel Java. And what might parallel Java be? Well, it's Java for parallel computing and multithreading. No, wait, it's still broken. That's not right. Right, Java from a parallel universe, specifically the universe that I came from. And what kind of a Java might that be? Well, it is a Java without annotations. They were never added to the language. So let me tell you a little bit about annotations. What are they? I think most of you will be able to recognize the annotations in this piece of code. There are these things. They all have a little @ sign at the front. So those are the annotations, right? You all know what they are and what they do. It starts working again. That's nice. So why were they added to the language, you may add? Well, the answer is really, really simple. C# had them. C# added them in 2002, and then 2 years later, Java followed and also added them. Although C#, you know, they call them properties, I think, or something different at least. The same way we got generics, right? C# had generics, and then in 2004, when Java 5 came out, we also got generics. But in parallel Java, these annotations were never added. So why were they added to Java, maybe? Well, there are several reasons why annotations were added to Java in your universe. The first one was that you could add metadata to your code very easily. For example, you could give your co-workers some hints about the code that they were about to read, like, is this method overridden from some supertype? Or is this thing deprecated? Do I not want you to use it anymore? Or does it contain some warning that I know about but can't fix, so I'm just going to suppress it? So that's a nice reason for using annotations. Another one was that at the time you had these frameworks that used a bunch of XML to configure stuff, and we all hate XML, right? So being able to replace that with annotations and actually put that stuff into your Java code was revolutionary, and everybody wanted to use it because, you know, everything beats XML. So you got all these dependency injection frameworks that use annotations instead of XML to wire things together. Another reason is to generate code. You can use an annotation to tell the compiler or some external tool that on the spot where you put that annotation, you want some code to be generated. For example, if you use JPA, it generates a whole bunch of code in an entity that does a whole bunch of magic tricks so that you don't have to think about them. And we probably all know Lombok, which also generates loads of code that you don't have to type, which, you know, seems nice, right? Other reasons, it was used to modify the runtime behavior of your programs. For example, if you have a method that was never called, then you know, it didn't do anything. But if you put @test in front of it, then suddenly your test framework picks it up and runs it as if it was a unit test. Same with the transaction annotation. You would have some container that recognizes this annotation and decides to run everything that has this annotation, this transaction annotation, in the same transaction in the database. I have to stand a little closer, I think. And how does that work? Well, it uses a lot of reflection and, as I said, code generation. So reflection is used to detect that there are annotations in the first place. And then either through reflection, again, some behavior will be changed, or through code generation, some code will be added. Basically, I want to categorize this kind of work as magic. And a very specific kind of magic, I would call it dark magic. So what is the problem with this magic? Why do I think it is dark magic? Well, actually, it's not just one. There are problems. The first one is, you know, because it uses reflection, all of this stuff is checked at runtime, and we all enjoy a good runtime exception, right? Another problem is that these annotations are very weakly typed. What I mean by that is that I can have a method that is an auto-wired bean that is also a JPA column and a REST endpoint, and also a unit test at the same time, and the runtime doesn't care. I mean, the compiler doesn't care, but even the runtime would think this is okay, as long as you have the dependencies in scope. So that's a little bit weird. Another issue that I have personally come across is that it is stringly typed instead of strongly typed. It's stringly typed. What do I mean by that? Well, if you have an annotation, there is only so many data types that you can put into it to specify what you want out of the annotation. For example, if I have an endpoint and I do an add pre-authorize on it and I want to have it fully authenticated, this doesn't work because I forgot the parentheses. Who checks this? I don't know. The runtime maybe, I guess, when you try to call the endpoint. So, you know, you have to have unit tests, otherwise you won't find this. Another problem that I find often with annotations is the discoverability problem. because if I have an object and I want to call a method on that object, I can just start typing, and the IDE will help me and suggest a whole bunch of methods that I can call on that object. But if I put my cursor in front of a method declaration, I get no help from the IDE. I just have to know what annotation should be there. And if I don't know, I cannot find it. So that's pretty hard. You have to read documentation or learn the framework really well, which is something that you should do anyway, but you can't have everything in your head all the time. Debuggability is a problem. For instance, I downloaded a pet clinic demo application from the Spring Boot GitHub, and I removed a random annotation somewhere, and then I got this stack trace. It doesn't fit on the slide. I will highlight next all of the lines that can be found that can actually be found in my code, in the code of the pet clinic application, and I will fade out all of the lines that are framework related. It's not even at the top, right? So these stack traces can be very, very confusing. And the final problem that I want to mention is that because of all this reflection, if you want to upgrade to Java 9 or 11, because we're all going to skip 10, you will have a hard time because of the reflection. You will get, if you want to modularize your program, because of the reflection, you will get error messages like this one: illegal reflective access, and those suck. You don't want them. So it's very hard to move to modules when you use this much reflection. So what is the solution that I'm proposing? Well, I'm proposing that you just ditch all of the annotations and use plain Java and the lambdas that come with Java. I think all of the uses of annotations, almost all of them, can be solved by just applying some Java. Unfortunately, you still have to work with libraries and frameworks. And many of them existed before lambdas were even introduced. Because lambdas came in Java 8, which was introduced in 2014. So we've had 10 years of annotations and no lambdas. So I'm going to show you some examples of where it made sense to use annotations instead of lambdas, and also why it makes sense to use lambdas instead of annotations now that we have them. But the point is, these frameworks have existed for a long time, and it takes time for them to migrate to an annotationless world, if they are even going to do so, because why change something that seems to work? So what if they dropped annotations and embraced lambdas? That is what I'm going to show you in the next few minutes. I'm going to show you parallel Java, which has no annotations, no magic, well, almost no magic, and uses just plain Java, the Java that you also have. So for my first example, I'm going to look at unit tests. In your universe, you would have a method and add a test annotation, and then this thing is a unit test, right? I think everybody can agree with that. So what would that look like if you didn't have annotations? Well, okay, so this is the annotation. Well, it would look like JUnit 3. It's a partial win, right? We got rid of the annotation, but it still sucks. It still has magic because it still uses reflection to find the test method. You know this because it has to start with the word test, which is a kind of magic of its own. In the parallel universe where I come from, the test looks like this. So you have a test method that has two parameters. The first one is a string that describes my test case. And the second one is a lambda that contains the actual test code. So where I said that I would show you how things would have looked if we didn't have annotations and we didn't have lambdas. Well, that would look like this. And this is not an improvement. This is obviously not an improvement because it still has an annotation, right? In the parallel universe, therefore, we've had lambdas for a lot longer than you guys have, so this is what our test would look like. So the pros and cons of this. Well, actually, I could only think of one con. Maybe after this session, you can tell me some other ones, but it looks ugly without lambdas, but who cares because we have lambdas. A pro, though, is that we have a very clear description of the test because we can use a string, and a string can use these magical things called spaces. And that makes your test's description so much easier to read than if you camel case the whole thing. OK, so the next example is on the web. If you want to make use of a web framework, you will probably do something that looks like this. This is, again, taken from the Spring framework. You will have a get annotation, a get mapping annotation that, in which the endpoint is described. And then there is a method which contains the actual code that should be executed when the endpoint is called. Note that, again, there is an annotation in the method declaration there. In my universe, it would look like this. I have a get method that I can call with two parameters. The first one is the endpoint, and the second one is a lambda that contains the code that will be executed when the endpoint is called. It looks very similar, right? But it's different in some important ways. So if we didn't have lambdas, to come back to that example, it would have looked like this. I'm not even going to talk about that. It still has the stupid annotation. So yay for lambdas. A reason why this is nice is because now it is very easy to separate your concerns. One concern may be that you can separate the endpoint descriptions, the strings that describe the endpoints, and the actual code that is used to when the endpoint is called. This means that you can just have a list and a quick overview of all the endpoints in your system without having to scroll through a long Java file, because they are all on one line and the next. So that's nice. You can still have your cross-cutting concerns because there is also a before method that you can call, which is called whenever any endpoint is called. And if it passes this before lambda, then it goes on to the next bit where the controller is invoked. So this is a place where you can do things like authentication. So pros and cons. Again, ugly without lambdas. I'm sorry. Couldn't think of anything better. A pro is that you have clean separation of concerns, as I just mentioned. And another fun one, I mean, it's not really something that you would do in practice, I guess, but you could generate your endpoints just in plain Java code, because you can have a for loop, I is 1 to 10, and just have 10 endpoints generated with that little number in it. So that could be fun. I don't know if there is a practical use for it, but at least it's a possibility now. You can disable an endpoint if you say, well, the program is now in such a state that it shouldn't be called anymore. Well, just disable it. It's no longer there. OK, so about databases. Databases are also a place where you guys use lots of annotations. It kind of looks like this. Who has been to the session this morning about Kotlin versus Java? That's a lot of people. Recognize this slide? I mean, it was almost literally in their presentation as well. That's funny. I did not talk to them about this before. But as you can see, there's a whole bunch of annotations on your domain class. And because of how the framework works, you have a couple of fields that cannot be final. So your class has to be mutable. And also, you need to have an empty constructor. or it doesn't have to be empty, but it has to have no parameters, because that is what JPA will call all the time. In the parallel universe, your data class would look like this. It's just an immutable data class with nothing special and no default constructor and final fields. This is how you want your data objects to be. So what would a call to the database look like? Well, it could look like this, where you have an SQL statement that will be executed. And then when it is executed, it can be mapped to a bean, in this case, my data object. And I have to admit that this is the part where some magic still happens, because it uses reflection to look at what this class would look like and try to match the fields of the class to the output of the SQL statement. But it is very much possible to use a different method that doesn't have this reflection trick. It's just a little bit more verbose. How about transactions? I mentioned the transaction annotation earlier. Well, it's pretty easy. You just call the handle.inTransaction method, give it a lambda, and put a bunch of code in there, and everything in that lambda is treated as if it was in the same transaction. Pretty easy. You can call methods from there, no biggie. So, a downside of this, obviously, is that you have to write your SQL by hand. Another downside is that there is still some magic, some reflection magic. And there's also a bit more duplication between your SQL fields and your Java fields. So you have to weigh those in. But there are also some clear pros. For example, you can write your SQL directly. This is also a pro because when your queries get a little bit more complicated, then you don't always know what Hibernate would generate. And this can cause real performance issues in your application. So this way, you are always in control of what your database is executing. There's a clean separation of concerns. And you can have immutable domain classes. The separations of concerns is that you can have your domain classes separate from your database infrastructure code, so that you can use these domain classes also in other parts of your application. Or if you work differently, you won't have to accept the fact that your domain classes are mutable and they spread around your application. You'll have all kinds of mutable database-aware objects throughout your code, even if it doesn't do anything with databases. So in this way, you can separate those concerns very clearly and easily. OK, so the big one, dependency injection. I've noticed in your universe that you are mainly using Spring and Juice as dependency injection frameworks. There's probably some others, but these are the two important ones. So let's talk about Spring first. Dependency injection with Spring looks a little bit like this. You have a class that contains a field. You put an auto-wired annotation in front of the field, and then Spring will know that here is a value that should be injected to that field. Somewhere else, you can have a bean, a method of a certain type with a bean annotation. And if it has the same type as the thing that is auto-wired, then Spring will know, OK, I can put that thing in the other place. So that's how it works in the basics. Although it's probably better to use a constructor instead of a field, because that way you can use you can make some fields final. That's nice. And if you use a constructor, I discovered when I was researching this, you apparently don't even need the auto-wired annotation for some reason. So yay, one less annotation. I have a problem with this, though. It's about architectural boundaries, because I can put my bean inside a class called I have something, which is the funny name that I came up with when I was writing the slides. But I can also put the bean in my main class, or I can put it in my employee DAO, or I can put it in some util class somewhere, or I can put it wherever. So, we need boundaries, and Spring doesn't really give them to me. There's also some mistakes that you can make. For example, if I forget to put the bean annotation, then I will get, a big stack trace. Let's play the game that we played before. I will highlight all of the lines that are actually relevant to my application and not framework code. It's this one. It is way down below, and it isn't even related to the part where I forgot the bean annotation or the part where I actually needed the object. It's just the main method of the main class. So that's not really helpful. The thing that is helpful somehow is these messages that are included in the exception, but I have to scroll all the way to the right to actually see what went wrong. So that's not a big usability win, I think, for Spring here. Another problem that can occur is when I have two matches instead of none. So that would look like this. I have two beans. They both have the same type. And which one does Spring pick? Well, it doesn't pick. It will abort starting the application and give you this message. And I have to say, this message is pretty clear. It's pretty obvious what you need to do. So, that's an improvement over the previous one. But it has one big flaw. The big flaw is that it is not a stack trace. It is actually something that is sent to the logger. And I can disable that very easily. I mean, I would be an asshole if I did, but it's very easy to do. And if I did that, then the error message goes away. You will never see it, but the program still fails to start. Well, good luck debugging that one. Finally, cyclic dependencies, also very easy to do in Spring. You will just have to add a parameter to your bean methods. So I have a something and a something else, and the something needs the something else, and the something else needs the something, and now I have a cyclic dependency. What will happen if I run this? Well, I will get this error message, again to the logger, but hey, at least it's clear what it says. It even has a nice little ASCII art circle in there. Well, circle, it's more like a box, right? Okay, so that's pretty easy to fix, I guess. Let's look at Juice. Juice looks very similar to Spring, but it has some differences. The first thing is that it uses an inject annotation instead of auto-wired. And the second one is that it doesn't use bean annotations. It has a module class that contains a bunch of bind statements, where you can bind your classes that you want to provide to the system to an instance or to something. So at least here we have an architectural boundary, because there can be one module, and once you have found the module, you have found all of your beans, right? All of the things that you can wire into your code. So at least that problem is fixed here. But what happens if you have no match for a class that you require? So I commented out the bind statement, and now I get this error message. It's still a runtime exception, but it is pretty verbose. It has a lot of information, and I can really easily see what I need to do, because it says no implementation for something was bound while locating something for the first parameter of this class where I use it. So that's nice. I can easily see what the problem is, but only at runtime. What if I have two matches instead of 0? Well, that would look like this. I have two bind statements to the same class. Probably in real life they would be further apart than the next line. But just to make a point. What happens if I do that? Well, I get a stack trace again. And at least it's a proper stack trace this time. So no way to hide it from the logger or something. And again, the message is pretty clear. So that's a win for Juice. Cyclic dependencies, Well, I kind of tried for 20 minutes and then I couldn't figure out how to do it. I still think it should be possible. If somebody can tell me afterwards how they did it, I would like to hear it. But at least it's difficult. So, you know, it's not easy to make this mistake in Spring, like it would have been in... I'm sorry, it's not easy to make this mistake in Juice, while it is easy in Spring. OK, so what do we do in our parallel universe? We do our dependency injection manually. There are no frameworks. You don't need a framework. It's very easy. So again, I have a class that needs a something. And I have a little bit of code where I actually create an object of type something, and then I pass it to the constructor of the thing that actually needs the something. And I do this in my main method. And that's it. Very easy. So the architectural boundaries, again, are pretty clear because you always know where to find your wiring because it's in the main method of the application. What happens if I have no matches for my object? Well, I comment out the declaration of my something, and then I have no somethings anymore, but I'm still trying to put it into my constructor, so I get a compilation error. You know, that's pretty obvious. It's very easy to see what needs to be fixed, because I don't have this object. What if I have two matches? Well, I can instantiate two objects of type something, but then I really need to choose one of them to put into the constructor, because I can't put in two objects in the same constructor slot. That just makes no sense. It's not possible in Java. It's not even possible to conceive of it in Java. Cyclic dependencies, same thing. You know, I have a something that needs a something else, and I have a something else that needs a something. Well, if I create the something, I would first need to create the something else. So that's a problem. So let's turn them around, and now I have to have a something before I can put it into the something else. And it's not representable in Java. Very much like the word on this slide, it's not representable. I mean, really, you guys laugh about this really awful joke? Really? This is a really bad universe. So the pros and cons. Well, the cons are obvious. It uses a lot of boilerplate. You have to write a lot of boilerplatey code. And it also contains a very dirty class, because we have learned that calling new from your classes directly, it's dirty. You need dependency injection. And here we are with a big class that only contains new calls. So that's one dirty class. That's a big con. The pros of this method over what Spring and Juice do, though, are pretty big, because illegal states are almost not representable. You cannot make the mistakes because the compiler will just say, what the hell are you doing, guy? It's not possible. And because the compiler is the one who says this, you will find your mistakes a lot sooner than you would when you have to start your application first, and then you will find them at runtime. Over Spring specifically, you get much clearer architectural boundaries, which is nice. And also, it boots much faster, because have you ever tried starting up a Spring program? Well, you have to start up that server thingy. It takes a little while. And if you just want to fix a typo somewhere, it can be pretty annoying, especially if you introduce another typo and then have to go back again. And we all know, we have all been there. So about this boilerplate, I actually think this is also a pro, to be honest, because at least everything is explicit and everything is in the same place, and you can find it. So this really helps if you are discovering a new project. You've just been assigned to a new project and you have to learn the code base. If there's just a big main method somewhere that contains all of this wiring, it's pretty easy to see what goes where. If you have to go chase down bean annotations in your Spring application, it's a bit harder. And it also helps when things get complicated in your code. So again, because it's so easy to find stuff. Other annotations. Well, I wanted to sweep those up a little bit faster. So I have seen annotations for serialization code. I have seen annotations for validation code. I've seen annotations for code generation. And they have all bitten me at one point or another, where I would get an error message because I made a mistake, and then I couldn't understand the error message or find the place where the error was. Serialization, for example, if you have a serialization issue in your REST endpoints in a Spring application, it can be pretty hard to find out what the error was, because at least in the programs that I've worked on, the error message wouldn't tell me. So good luck finding what the problem is. There are some annotations that I don't hate as much. For example, non-null and immutable and these kinds of things, because they tell you something about the code. And usually they also tell you something that a static analysis tool can verify. So if you have static analysis on your program, you can use some tooling to make sure that your code is working, is doing the right thing with those. So that's a little bit better. There are even some annotations that I quite like. Override is one good example. I mean, that one is so good that Kotlin and Scala actually made it keywords in the language. Good thing. And deprecated is also pretty useful sometimes. So this parallel Java thing that I've been talking about, you will probably be thinking, well, yeah, right, that cannot be real. Maybe it is real in my parallel universe, but what can I, as a developer in this universe, do with it? Well, actually, all of the code I showed you is real. There's a GitHub somewhere. I'm going to give you the link later on. Because to see if my claims were actually true, I decided to implement a little program. So most of you will have probably heard of the To-Do MVC project, where you can try out a little to-do app in many different technology stacks for the front end. Turns out there's a similar thing for the back end, where you can have a little back end for your to-do app in a lot of different technology stacks. And they have a test suite that you can run. So I decided to implement this application and run it through the test suite, and I can happily tell you that these are the results of my program. It's fully compliant. So I have been able to write an application that, well, it's pretty simple, but still it does some real things. And for example, maybe if you can read, I don't know if you can read it at the back, but the first test is about course headers. So the security things are also just possible and they work. So what does the code look like? Well, first of all, I will show you my POM. I was a little disappointed to find out that you guys use XML for your POMs. I prefer to use YAML. But as you can see, it is all written in Java 11, and in fact, it's all modularized completely, which was pretty easy to do. I also have a little check style rule that detects all of the @ signs in my code and generates an error if it finds one. So, that was just to keep me on my toes. Annotations are not allowed in this code base. This is an actual unit test. I am using ArcUnit to test my architectural boundaries so that I am not using database-related code in a package that shouldn't be dealing with databases. This is where I define my endpoints. So first of all, I tell the application to listen on a certain port. I enable the course headers. And then I have a get endpoint for, I have two get endpoints. One is one that returns all of my to-dos, and the second one is an endpoint that returns a specific to-do. I have a post to create a new one, and I have a bunch more that I didn't put on the slide. And they all call a controller, which handles the actual request, which is in a different class. I have a little bit of database code. I can insert into my table. I can bind. I can use this bind method to bind certain values to my database fields, which is nice. And this is my main method, or at least part of it. As I told you, it contains a lot of calls to Java's new keyword. But it is pretty clear what is happening where. As you can also see, it's written in Java 11. I use var a lot. That is nice because it will line up my identifiers really nicely. The libraries that I used in this application are real. You can use them. You can, they're on Maven Central and everything. I used Spark Java as the web framework. I used JDBI as the database framework. Spoiler alert, JDBI also has some support for annotations, but of course we don't use those. And I have used a library called Picotest as my test framework. And unfortunately, Picotest exists in my universe, but it did not exist in yours. And it's pretty hard to set up a GitHub fork from one universe to another, so I had to re-implement the whole thing, unfortunately. But it exists now. I have published it to Bintray, and you can actually use it. You can find it on GitHub. So I have parallel Java that contains the to-do backend, and I have Picotest that contains the test framework. So concluding, when you are working on an application and you decide to add a library to your code, you should really think about that. Is it something that you really need? Is it being a good citizen? Does it have an excessive amount of annotations that you should be using? Does it have other problems? Just the fact that it's popular doesn't mean that it is necessarily a good library, and just that it is unknown doesn't necessarily mean that it is bad. So, keep an open mind. Same goes for your frameworks. Try to find one that doesn't infect your whole architecture, and look if there are no alternatives. I mean, even Spring is now working on a framework, a web framework, without annotations, and that uses lambdas in a way that is very similar to Spark Java. It's called the Spring Functional Web Framework. It's not ready yet. It's not released. Well, it's released, but it's not. You shouldn't be using it in production yet. But at least they're working on it. So even Spring are moving in that direction. Another thing is you should be thinking about the languages that you use. Is Java the best choice? Maybe you have learned something during your Language of the Year experiments, found a language that you can apply. Maybe that would be Scala, maybe that would be Kotlin, or maybe parallel Java. It's a really nice language. I can really say that it's very nice. I had a lot of fun implementing the to-do backend. And finally, think about your universe, because this thing is really broken, I think. I'm stuck here. I can't go back home. I would like to go back home. So if you can help me with that, please let me know. But before you do, please rate this session in the JSpring app. And are there any questions? Are there no questions? Over there, yes. Well, I have some coworkers who also don't like annotations, just like me, but I'm the crazy guy who went ahead and actually tried to build something without them. And they are happy that I'm giving this talk here, but they're not actually present, unfortunately. So there's no cheering. Other questions? No? Well, then I guess we can go to drinks a little bit early.